Okay, today we're going to be looking at energy conversion and actually calculating efficiency of energy input. So first let's review. The law of conservation of energy says that energy cannot be created or destroyed. This is just like the law of conservation of matter. Energy can only be transformed from one type of energy to another type of energy. So again, review, we can take things like sunlight, which is light energy, and switch it into chemical energy in the form of food. We can take electrical and switch it into thermal energy, so electricity into some sort of heat. We can take chemical energy in the form of food and change it to mechanical by riding a bike, and we can take chemical energy in gasoline and change it into mechanical, again, in your car. So energy conservation or energy conversion is changing one type of energy to another type of energy using a converter device. And if we are going to conserve energy, that means that we're having as much energy input as we are having output. But that doesn't always happen. The energy output isn't always useful energy. So sometimes that useful energy is lost when energy is converted from one form to another. So for example, if you put 100 gallons of gas in your car, only 25% or 25 gallons of that gas actually makes your car move, which means that your car is only 25% efficient. So when we're looking at like TV ads and things like that, talking about cars that are more or less efficient than others, they're looking at how much of the fuel, the energy that's put into it in the form of gasoline, is actually going to moving the car forward. So when we have energy input, some sort of conversion device, and then energy out, the useful energy output, if we divide the energy output by the energy input, we get the efficiency, and then we can times that by 100 to get the percent efficiency. So practice. If we put 100 gallons of gas in the car and 30 of those gallons are used to actually move the car, what is the conversion efficiency for that vehicle? So we got energy output divided by energy input. If we have 30 gallons of output, 100 gallons of input, that means we have a 30% efficient vehicle. Another practice. A certain light bulb consumes 200 joules of electrical energy per second, but only emits 25 joules of light energy per second. So it's taking in a certain amount of electricity and it's only giving off a certain amount of light. So we're going to calculate the efficiency of this bulb. So first we need to think about what is our actual output, our energy output, and what is our energy input. So here the output is the 25 joules per second, and the input is the 200. So we're going to take 25 divided by 200. That gives us 0.125. Times that by 100, and we get 12.5% efficient. So that is not a very efficient light bulb. And actually, if you look at a lot of light bulbs, they're not very efficient as far as the energy input versus output. If there are any practice problems on your page, make sure you do those, and then go ahead and complete the choice activities.